Good evening, good afternoon, everyone. I am Grace Merveill Mikala, a PhD student at Marien Ngouabi University. Today, the pleasure is mine to share with you my work about phytochemical study and anthelmintic activity of 9 Congolese plants. To introduce, African flora is rich in plants, with medicinal plants occupying a prominent place. For a number of reasons, people of Africa are increasingly turning to nature to find solutions to fight the illness. According to WHO statistic, 80% of population now use plants to treat themselves. Among these medicinal plants are those that fight intestinal parasitosis. Despite the progress in the field of preventive medicine, gastrointestinal parasitosis remains a public health problem in tropical countries due to the lack of inadequacy of hygiene and sanitation measures. The phenomenon of chemoresistance caused by the use of synthetic anthelmintics and the failure of health centers to screen the population on an ongoing basis. Concerning methodology, various plant organs were harvested, dried, and ground. The powder obtained were used to prepare the extract. Following the recommendation of traditional practitioners, aqueous extracts were prepared by decoction and maceration to assess the anthelmintic potential of selected plants. Selective extract obtained by liquid-liquid extraction with solvent of increasing polarity were used to identify the chemical families present. The anthelmintic activity of the plant was assessed using the method of Gisu and collaborator. Earthworms were placed in 3 petri dishes, and solution of aqueous extract prepared at concentration of 10, 20, 25, and 50 milligrams per milliliters, respectively, were added, and the behavior of the worms is observed over time for 24 hours. Talking about chemical screening, thin layer chromatography was used to identify the chemical families, using specific developers for each family to be researched. The figure 2 summarizes the procedure used. Concerning result and discussion, phytochemical screening using thin layer chromatography revealed 6 chemical families as terpenes, sterol, flavonoids, tannin, polyphenols, and alkaloids. These chemical families were present in all the plants except for alkaloids, which were found only in the roots of R. manii and the leafy stems of R. conizoides. The plants that showed the lack of these families were G. cola, R. conizoides, and R. alboviolaceum, and C. podoliana leaves. All the plants showed anthelmintic activity at concentration considered, but it was more significant at 50 milligrams per milliliters in comparison with mebendazole. In fact, total worms mortality for all plants was observed between 0 and 10 hours at 50 milligrams per milliliter, 0 and 20 hours at 25 milligrams per milliliter, and finally between 0-1 hour and over 24 hours for the 10 milligrams per milliliter concentration. The plants that show the best anthelmintic activities were P. guinensis, R. conizoides, and R. alboviolaceum. It was very low for M. lucida, C. podoleana roots, and R. buettineri. At last, we can say that all the plant studies showed anthelmintic potential with the presence of terpenes and sterol, polyphenols, flavonoids, alkaloids, and tannin. The most active plants were P. guinensis, A. conizoides, A. alboviolaceum, and G. cola. These results could justify the use in traditional medicine in the Congo to combat intestinal parasitosis. Studies on other types of parasites are underway to confirm the biological activity of these selected plants. Thank you.